Bill Arnold with the ALCF. I'm going to talk about the details of actually using the Bo Pod64 system that we have at ALCF. Um, a system overview, how to get account access, how to log in, how to set up a virtual environment, and workflow. I'm going to also show a live example of the things that one needs to do on the command line. So we've been through this before. We have a 64 IPU system with four nodes that you can, or three of which you can SSH into. It's a single rack. And the systems that you can SSH into are the second, third, and fourth node. And when you launch a job, you tell Slurm to allocate some of the IPUs for your job. They might not even be on the, or they're somewhere in the rack, but they're not actually associated with the node directly. First thing you have to do is, if you haven't already done this, is request an account, an ALCF account, and it's at this link, accounts.alcf.anl.gov. And the creation page looks like this. There's a menu on the left, request an account, and once you've requested an account, then you can log in, and you're logging in with the crypto card. Once you've logged in, the menu on the left changes. You can do some other things, including join a project, which in this case you want to join AI Testbed training, unless you have another project that you can join that you're going to use. And once you've done that, you need to check the request and view systems pull down icon on the left, and make sure that Graphcore is listed in the list of available resources for you. Once you logging in is a two-step process. You have a login node where the authentication is done using the Mobile Pass or the Mobile Pass app on your phone. There are two login nodes. Once you've logged into a login node, you can SSH to Poplar node 2, 3, or 4. The only authentication is happening on the first login to the login node. Beyond that, there's no authentication required. This is also documented on our docs website, and you can see the URL is here. docs.alcf.anl.gov is where you want to go, and then you can drill down from the menus from there. The first node, just a note, the first node is not accessible to users. You can't SSH into it because it runs some control tasks, but its IPU resources, such as, well, the IPU resources are of all 64 nodes are available to Slurm tasks, and they're not actually associated with the nodes. I'm going to go through this live, but you're going to need to create an environment. The environment creation process is fairly quick. It takes, I timed it earlier, about a minute. We have other older SDKs on the system. By default, the 3.3.0 SDK is activated. At some point soon, we'll upgrade to 3.4.0. But we keep the old ones around if you want to use them for some reason. There's some environment variables that you'll probably want to set. I put these in my .bash RC. The first set enables the cache, compile cache. If you don't do that, you'll end up having to compile each time, even though you haven't changed the model. And you might want to also set the logging levels for the various parts of the system, software stack. So again, I'm going to show this slide, but you're going to want to create a virtual environment. You're going to want to install either TensorFlow or PopTorch into your virtual environment. So if you're just working in one or the other, you can create one. If you're working in both, you can create both. It's still only going to be a few minutes to create all of your virtual environments if you create both of them. And the wheel files are local on the system. And when we update the system, the wheel file names will change. The documentation online that we keep will also be updated. Again, you can see this at our documentation website, docs.alcf.anl.gov, and then drill down. The examples Alex was showing, this is where we normally have people clone them to. We generally advise people checking out the same level of examples code as what's installed in the system. So in this case, we're explicitly getting the tag v3.3.0. And then running an example, I'm going to show this slide. So probably no reason to go over this slide. This is the more complicated example, the GPT-2 example. The command line is long. Basically, the application is more complicated. Again, you can find full details on how to run these in the online documentation. And I advise you to use the online documentation because copy paste is more reliable from there than from PowerPoint. There's utility commands that you need to know. There's the SERM commands. srun is how to run a job. sq is how to look at the jobs in the queue. scancel is how to cancel an existing job. You can also just Control-C it if it's an interactive job. Sinfo views the partition information, so you can see if there are nodes that are in a bad, if there are things that are in a bad state that are surfaced up to sinfo. And then there's a gc monitor command, which will which you have to specify all partitions to, which will give you all of the IPUs being used on the system. Let's see, these are some of the common links that you want to look at, but basically docs.graphcore.ai, as Alex says, the documentation is very good. It's mature and it's well written. I strongly suggest looking at the documentation and searching it if necessary for things that you need. PyTorch user guide is here. TensorFlow user guide is here. There's an IPU programming guide, and then the GitHub repo, basically github.com/graphcore, and then you can look at the various repos that are there. On the ALCF testbed systems, you have some common directories. Your home directory is shared across all the testbed systems, um, and there's also a local data for things that you need to store locally to the node. Um, there's a slash software datasets directory where there's some common data sets. Um, the SDKs, the various SDKs are stored in this directory here. And I think that's it for slides. Oh, there's a director's discretionary allocation process, and you can click on that link there, um, which you'll I didn't write it out, so you'll have to basically go into the slides um, to click on that, or maybe we'll put it in the chat. And allocations are also available through other processes as well. And that's it. Now I'm going to show a live demo. So I'm sitting at my laptop. First thing I need to do is assess SSH to a login node. I've already I've already gotten the access and I've already logged in, so it's not going to ask for a password. Otherwise, you would have to use your authentication device to get the password. Once I've gotten into the login node, there are a few things that I can do in the login node, but really you need to log into node, a node on the Graphcore rack, and you get your standard warning. First thing you need to do is make a virtual environment. I'm just going to make the PyTorch environment, and I've already made it, so this will be real quick. And I'm sourcing it to make sure that it's active. Then, again, this will be quick because I've already made it, but this is how you install the wheel file. It's a single wheel file for PyTorch, PopTorch. I timed this earlier, and I recall it took about a minute. Make sure that you have a copy of the model, the examples. Well, I had a networking freeze just there.
So we can hear you. The video is a bit slow, but that's fine.
Yeah, I have pings going on in another session, and my ping times are up to like 5 seconds. Okay, so here is I checked out, I've cloned the repo and checked out a particular tag, the 3.3.0 tag. All right, seems to be back to normal again. So I'm going to show the things that I normally run in my bash RC. First, I set up the cache, and this is the compile cache. Basically, if you don't do this, it will recompile, even though the model hasn't changed. And I also set um, the logging levels to warn. I'm not sure what they are by default, but I always do this. I already have the virtual environment active, but just to make sure. And this is the MNIST sample. Oops. There we are. All right, here's the MNIST sample. And I'm going to show the cache. So I ran this earlier. These two items are in my cache. I had cleaned it out entirely earlier. So I'm going to remove those just to show what the compile looks like. And then I'm going to run that sample with just 4 epochs. The default is 10. And so this is a basic sample, of one IPU sample. And this is what running a small sample will look like to you. The allocation, the S-run seems to be a little slow today, so it does eventually trigger. You can see the compilation actually gives a progress indicator, which is nice when the compiles are longer, as they are for larger models. And most of the samples have this progress indicator. Now, if I had another window open, I could look at GC monitor and see the IPU in use and some details about how much power it's using and that kind of thing. And it's compiling again for evaluation, I guess. And hopefully prints the model out after it's done, or model summary out after it's done, and give some statistics. So basically, that's how you run a sample. Alex showed some other things, and I strongly suggest looking through all of the tutorials that are of interest to you. I guess that's it. I'm not going to show any other samples. We might show some longer, bigger samples tomorrow.